High definition, high resolution. What does it mean in the digital signage world? Let's talk about it. My name is Mike Heffron, partner at Liquid Video Solutions. Welcome back to the channel. High resolution. What does it mean? By simple definition, it is a display or image showing a large amount of detail. In print, it's measured in dots per inch, or DPI. In audio, it's measured in the number of samples per second. And in digital, it's measured in the number of pixels, and then down to the color depth and the frame rate. Now, in case you're not super familiar with screen resolution, I'm going to use an example that you'll probably recognize, and that's 4K. 4K television, the new standard in home viewing resolution. In a home context, 4K means the screen resolution is a minimum of 3,840 pixels wide by 2,160 pixels tall, which is double what we call full HD, 920 by 1080 pixels, or 1080p, as seen here on YouTube. Less pixels typically means a softer looking image, while more pixels means a sharper looking image and higher resolution. Okay, let's take this principle over to direct view LED signage. Now, this type of flat panel display is made up of thousands of individual light emitting diodes, or LEDs. Each one of these diodes will act as an individual pixel in your image. So more pixels typically means a sharper image, thus a higher resolution. Now, when talking about direct view LED, you're going to come across this term, pixel pitch. Now, stay with me here. It gets a little confusing, but we're going to get through it. Pitch refers to the distance between pixels on a specific LED display module, usually measured in millimeters, from the center of one pixel to the center of the adjacent pixel. Now, since pixel pitch is an amount of space between pixels, a lower number of pitch means a higher pixel density, and thus a higher resolution. So unlike before, when a higher number means a higher resolution, in the terms of pixel pitch, a lower number actually means a higher resolution. Pixel pitch is extremely important in direct view LED because it determines your optimal visual acuity distance. This is also called Retton the Distance. It's a calculation to know the distance a person with 20/20 vision must stand away from the display to see a full HD image with no pixelation. Now, keep in mind, this doesn't mean that your display won't be readable at a closer distance, but the closer you get to the display, the more pixelization is going to occur and the less resolution. Now, this would be really easy to understand if all LEDs were made the same, but they're not. LEDs themselves come in countless varieties, and to go into all the detail could fill up a whole YouTube channel by itself. So for this application, we're going to focus on single color LEDs versus multicolor LEDs. Now, I got to back up for a second, because in order to relate this to pixel pitch and resolution, we have to first understand that in digital displays, color is presented through the RGB Color Model. RGB stands for red, green, and blue. This color process combines the colors to create millions of color varieties. We'll go deeper into color theory in another video, but for this video, just focus on the fact that each pixel needs to contain a red, green, and blue light to function. If you see older or less expensive LED displays, they'll use an individual single color LED for each specific color. So up close, they look just like an old Light-Brite toy that you may have played with as a kid or still might play with now. They have one red LED, one green LED, and one blue LED clustered together. And these three create one pixel. Because the pixel is so huge, this means it's going to have a very high pixel pitch, lower resolution, and less powerful colors, since the distance between the additive LEDs is very large. Better displays combine all three colors into a single LED, dramatically decreasing the distance between the pixels, creating a higher resolution, better color, and some even add a white into that single LED, giving you the power of true white and increasing all the available colors in your spectrum. Now, let's talk about viewing angle. This is measured in degrees and equates to how off-center you can be to the display while still being able to see the image. On less expensive LED displays, you'll notice that as you walk off-center of the screen, the image just disappears. That's because it has a very narrow viewing angle. Now, better LED displays are going to have a wider viewing angle, anywhere between 120 to 160 degrees. This means that you can see the image from any vantage point until you physically pass the side of the screen. Now, I want to discuss one more thing before we end this video, and that's the last piece of this resolution trifecta, and that's refresh rate or frame rate. Refresh rate is the number of times per second that an image is shown on a display. Images and video on an LED screen or a TV are created by hundreds of continuously refreshing images. And these are imperceptible to the human eye, but have you ever tried to take a video of an LED screen or a TV, just like on your cell phone or something? Refresh rate is not necessarily baked into the content, but in fact it relies on the power of the display hardware itself. A higher refresh rate results in a smoother and clearer image, which means higher definition. In professional uses, it is crucial that you use a display with a very high refresh rate, because eventually you or someone will want to take a picture or a video of it. Now you understand a little bit more about screen resolution and how it plays a part in the digital signage world. If this video was helpful for you, please like and subscribe. Our channel is all about digital signage. We'll have more tips and videos like this coming your way. Reach out to us anytime at liquidvideosolutions.com or drop a question in the comments below. We'll be checking back and answering everything you guys are asking about. So until then, keep creating, keep innovating.